So I'm doing this because we're not sure, I would have waited till next week, and I know you haven't really practiced the definite interval. But anyway, so that'll be next week, you get to practice that, okay? I'm not gonna assign anything on any e-learning days, and God forbid we have to do a Google Meet, that would be on Wednesday after. I can't imagine that we would need that. Can't imagine. But anyway, just in case. So Monday and Tuesday, you can practice, what is it, 6-6, the one we did yesterday, and this next week. When I do see you again, we can pick up with those two and answer any questions, do some more examples, whatever you need. Okay, at least these two things, because this is what I have planned for. I think next week is just those two. Let me double check. I don't want to get one class confused with another. Let's see, next week is the last weekend in January. And I have 6, 6, 6, 7, so this will be good for all week. 6, 6, and 6, 7 will be good for all week. Okay. Hey, how are you gonna integrate if any differentiation formulas don't work? Those sheets I gave you, you look all over and maybe you even tried a couple and didn't work. Oh. One way is this substitution rule, okay? What we're going to do is we're going to introduce a new variable. It's often considered u. Sometimes you hear u substitution. Similar to what we did with the chain rule, but this is not the chain rule. Because we're going in reverse, okay? So we did sort of a u substitution in the chain rule, right? And then we got to a point where we didn't have to do that anymore because I was able to see the inside function. Okay. So, again, this is going to look confusing. This method works when we have an integral that can be written in sort of this form. F of something, I see a function, f of something, well, it's the integral of f of something, and then for some reason I see the derivative, or some form of the derivative of what this thing is. Okay, so that's really the same thing as this, remember, right there? We'll give you the antiderivative, so if you take the derivative of the antiderivative, you got that back. So that's the derivative of the antiderivative, which is that again. Okay, same thing. But let me show it to you with the u substitution. And don't be like LeBron. Plus. Embarrassed. Okay. So really this is what we're looking for right here. So if I see a function and I also see some form of its derivative, I'm gonna let that function, I'm gonna rename that as u. It usually is the most complicated part of the integral. And then, because I changed the x to a u, I'm going to have to change dx to du. And you'll see how this works. When I show you a couple of examples, doing it actually makes way more sense than talking about it. So here's what we want to look at the integrand and think about taking the derivative of it. If the derivative requires the chain rule, then the antiderivative is going to require u substitution. I say, look at the integrand, look at the most complicated part of it, and see if I took the derivative of this thing, do I see part of that in there? That's what I look for. I look for the complicated part, and then I just say, if I took the derivative of it, do I see that or some of it? Okay, because here's what we're going to do. If u equals, we're going to substitute u for that function of f, we're gonna say, hey, this is the more complicated part, we're gonna let that be u. Then du, the derivative, will be the derivative of that. Again, talking about it, what's he talking about? We'll get there, okay? The whole point of this is, and you're going to see it today, is to replace something that looks kind of complicated with something that looks pretty simple. Trust me on that, okay? And here's where I say, try to choose u to be some function in the integrand whose differential derivative also seems to be in the integrand. Okay, so we'll do that a couple of times, maybe more than a couple of times. Don't forget, you're probably able to do a lot of integrals without substitution. It seems like every year, when I introduce substitution and we play with it for a few days, and all of a sudden everybody wants to use substitution for every kind of integral. And no, you don't have to, okay? Only when it looks kind of complicated. So, shall we try some? We ready? Oh, I'm not. So I've given you the examples I'm gonna work up here on the board. And I'll work through a couple, and then you can help me with a couple. And then we should be good. And then you can try the assignment. So I look up here, and first of all, this is in the lesson involving substitution rule. So I bet there's gonna be some substitution in every example, okay? I look at this, I mean, how would you do this just based on those formulas we have, those antiderivative formulas? Looks bizarre to me, I don't know how I would do that. But you know what? I see something where I also see its derivative. I see this, and I also see its derivative. And I know, if I'm looking at this, I probably had to do the chain rule, right? I probably had to do the derivative for this times the derivative of the inside. Oh, so if I had to do the chain rule, I'm probably gonna have to do this. So here's what I'm going to do. I'm going to try to simplify it. I'm going to let u equal x to the fourth plus 2. That means du will equal 4x cubed plus 11. Right? The thing I don't see up here, I see the x cubed, right? I don't see a 4. So here's what I'm going to do. Just divide the 4 over here. And that will allow for a quick substitution. Then I can rewrite this integral with the u. Here's what I've got. This will equal the integral. We put this. Sorry. So x to the fourth plus 2 will be oops, sorry. I probably did this. I took that derivative in terms of x. Forgot the whole important part. Okay. So u cosine of u, and notice this. X cubed dx. I can just make that 1/4 du. And I know from my properties of integrals that if I have a constant, I can just pull that out front. And then do the integral of cosine of u gotta have the du because you've changed your variable from x to u. I got this 1/4 outside. Hey, what's the integral of cosine?
Sine.
Sine, right? So that just becomes sine of u. So we just took the integral, it wasn't a definite integral, plus c. What am I gonna have to do now?
Substitute u.
Gotta substitute back in because the original was in terms of x. So this is going to equal 1/4 sine of, u was x to the 4th plus 2 plus c. And of course, you could always take the derivative of that and see if you got that back. So that's what we want to do every time. Cool? Okay. Do it if you cannot find an antiderivative already. I would look for an antiderivative first, and then if you can't, well then try u substitution. No questions on this? Cool. Try another one? Okay. Gets to the point where this is actually kind of fun. Trying to make the pieces fit together like a jigsaw puzzle. Okay, let's look at number 2. I got the integral of the square root of 2x plus 1 dx.
2x plus 1 to the 1/2.
Yep, we could do that. Nothing wrong with that. That's 2x plus 1 to the 1/2 power dx.
So u equals 2x plus 1.
Yeah, let's try that. So let's let u equal 2x plus 1. du, the derivative of that would just be 2 dx. Remember doing that? The derivative of this is in terms of u du. This is in terms of x dx. Yeah, we did that one.
Divide by 2.
Yeah, I don't see a 2 up there. So it'd be nice to see what I see up there, which is just dx. So 1/2 du. Hey, that's going to allow for a simple substitution. So I can do this now. I'll substitute. This would be u to the 1/2, and dx can become 1/2 du. Now, because I have that constant, I don't want it to get in the way, so I'll just pull that out. And I'll do the integral of u to the 1/2 du. And so we got the 1/2 out here. Let's go ahead and take the integral. Remember, just add 1 to the exponent and then put that in the bottom. So that's going to be u to the 3/2 over 3/2. Instead of putting it over 3/2, why don't I flip it 2/3? So I notice my 2's will cancel out. So that's going to be u to the 3/2 over 3 plus c. Ooh, I forgot my plus c. Don't know if I can go any further, so it's time to substitute back. So this is going to be u was 2x plus 1. 2x plus 1 to the 3/2 power over 3, or you can say 1/3 times that. Let's see. Some ways U substitution can be even easier, because if you see the substitution, chances are the antiderivative that you're looking for is kind of easy. Questions yet? Oh man, we're just breezing. Just like yesterday, man, it's like flying. Okay, let's look at this one. I'm really not sure what I could do. I looked all through the antiderivative formula sheet and I didn't see anything. So I might want to try U substitution. Is there something I can plug into U that when I take the derivative, I see its derivative or at least part of it? Probably the more complicated part.
1 negative minus 4x.
Try this one, 1 minus 4x squared. If I do that, then du is going to be negative 8x dx. Hey, look what I see. I see x dx. I see that. If this were just moved to the other side. So, divide by negative 8 du will equal x dx. Well, that'll allow for an easy substitution. Well, that means that I'm going to rewrite this then as 1, whoops, the integral, of 1 over the square root of just what's inside. You said just what's inside. Square root of u. And then x dx, that part will be this. Negative 1/8. And so I can probably pull any constants out, which would be the negative 1/8. Let's pull that out. Leaving me the integral of, can I go ahead and say that's u to the negative 1/2? Du? Is that okay to do that? Okay. And so now let's take the integral. I want the negative 1/2 to not get in my way. Add 1 to the exponent, u to the 1/2 over 1/2. Well, instead of over 1/2, can I just call that 2 over 1? I mean, I got 1/2 there, right? Just multiply by the reciprocal, 2 over 1. And then plus c. Let's see, I can cancel that 2 with a 4 down here. So it looks like I got negative 1/4 u to the 1/2 plus c. That's about as simple as I can get. Time to substitute back in. Negative 1/4. You know, this is a simple rational exponent. Maybe I'll do this again. Square root, whatever u was, 1 minus 4x squared. Plus c. Oh, this is the loud one. Anybody have any questions? It's so quiet you could hear a pin Okay, I'm assuming we're following pretty well. Let's just do a couple more, and then we'll call it.
I have a question.
Yes, sir.
How do we know that we can't like do more?
You mean like right here?
Yeah, like
In a simplified sort of way. I don't think I can simplify it anymore. It looks like everything that could possibly be canceled or combined has been canceled or combined.
so that is the integral,
Yes.
and there's nothing more simple.
Mhm.
Okay.
Yeah. We're getting into a little bit more complicated ones now. So, yeah, let's just do two.
Wait, Mr. What do we get, like the actual answer on the calculator? Because
On the calculator.
It has like a certain integral.
The calculator will give you a definite integral, but the calculator won't give you a function back as an answer.
No, indefinitely.
So it won't give you an indefinite.
Okay.
I guess I can't do both at the same time. But what you could do is you could always take the derivative, which would be using the chain rule every time. Because that's why we're use substitution. Take the derivative using the chain rule, see if you get that back.
Oh.
What you started with, so you could do that. Anybody have an idea of what they want you to be? Equal what?
5x.
5x. And then if I take the derivative of this, I get to u. If I take the derivative of this, I get 5dx. Well, I see dx up here. I don't see a 5 with it. So it'd be a perfect substitution if I could just move the 5 over here. du equals dx. Oh, that would be perfect. And then that will allow me to do this. Integral of e to the, well, we just said 5x is going to be u. We just said dx is going to be 1/5 du. Which I can definitely bring all the constants out, which is, in this case, just the 1/5, the integral of e to the u du, which we know. What's the integral of e to the u?
E to the u.
E to the u. With a 1 here. That'll be e to the u plus c. I don't think I can simplify anymore there. So it's time to substitute back in. 1/5 e to the u was 5x plus c. You'll probably not get to a point where we did chain rule, you kind of said, hey, derivative of the outside times the derivative of the inside. You didn't have to use the u eventually. This one, you're probably going to want to always use the u because you're probably going to manipulate the d in some way to plug back in. This is a good one. Let me pull it up. Everybody okay with number 4? This will be our last one. Now we're getting into some manipulations. I mean, this is pretty good if we finish with one. So we do have all next week. Okay. I really don't know what I could use here on that antiderivative formula sheet. I don't see anything. Anybody want to try some?
What, u equals 1 plus x squared?
Okay. Why not? If we do that, the derivative of u would be 1 du. the derivative of this would be 0 plus 2x dx. I definitely don't see a 2 up there. Do I see an x dx? I actually do. Square root of 1 plus x squared times x to the 4th times x dx. Oh, I do. If that 2 was over here, I would have this matching this. That's pretty cool. Okay, so let's move this over here. Divide by 2. So, this will become the integral of this, or do you want to call it to the 1/2 power instead of square root? So, that is going to be u to the 1/2 power x to the 4th, and that is 1/2 du. Still got an x in there. How can I turn that other x into a u?
Can you do it from the iPhone?
Yes, but we don't know that yet. Oh, it's staring right at you guys. How can I turn that x into a u? Or specifically the x to the 4th into a u. It's right there, it's hiding in plain sight.
So u minus 1 squared.
There we go. Yeah, that brings everything in terms of u. That's what I've got. What is it? U to the 1/2 here. And then I'm gonna substitute u minus 1 and make it squared. So since that is x squared squared would be x to the 4th. And then I've got a 1/2 d. See? If you have some x's left over, go back and look at what you said x was in terms of u. And you can bring that back in. Boy. Might have to do a little work here. Let's see, I know I can bring that 1/2 out, because that's a constant. I don't see any other constants. So that's gonna leave me u to the 1/2. Why don't I go ahead and square that? U squared minus 2u plus 1 du. And then we could probably just multiply this through, right? And then I've got 3 terms. Integral, let's see, well, sorry, 1/2. Don't forget the 1/2. Okay, so u to the 1/2 times u squared that u to the 5 halves?
Yeah.
U to the 5 halves. And that's gonna be minus 2u to the
3 halves.
3 halves. And that's gonna be plus
U to the 1.
u to the 1 half. And, hey, we could probably, hey, one of the properties of integral says I can treat each of those terms by itself, right?
Why 1.5 multiplied by 2 is 5?
Because this is the same as 4/2. And when you multiply with the same base, you add exponents. You sure?
I think so.
Okay, so we have the 1/2 here, so let's do each part by itself. This is gonna be u, add 1,
7.
u to the 7 halves, over 7 halves, and we'll clean it up. We got enough going on here, we'll clean it up next step. Hey, I can pull the 2 out, and then I've got u to the 5 halves, over 5 halves. Plus u to the 3 halves, over 3 halves, plus c. We could put the c inside the parentheses if you want to. 1/2 times c is still a constant, it doesn't matter. And maybe we want to, these multi-tiered fractions, they get on my nerves. Make that 2 u to the 7 halves over 7. And that's going to be minus 2 times 2u to the 5 halves over 5 plus 2 u to the 3 halves over 3 plus c. I don't want to do too much in one step because we might run the risk of making an error. But I noticed this 1/2 out here can cancel with the 2 here, the 2 here, the 2 there. So basically I'm left with u to the 7 halves, and then we'll have to substitute back in. Let's see, that's gonna be minus 2u to the 5 halves, 5, and plus u to the 3 halves over 3 plus c. And then all we have to do is substitute back in. Right? So, oh, this will be fun. Okay. Equals. What is u? 1 plus x squared. Okay. So we got 1 plus x squared to the 7 halves over 7 minus 2 1 plus x squared to the 5 halves over 5 plus 1 plus x squared to the 3 halves over 3 plus, let me see. That's pretty good if you have to put this on a free response, that's good. There is another step we could do. They all have something in common, but you don't have to.
Multiply. 7, 5.
We can pull out a 1 plus x squared to the 3/2 from everything. If you wanted to. This is not incorrect. But you see what I'm saying? We could do this. This is fine. That's fine. They're looking at this stuff. Okay? But if you wanted to pull this out, they all have this in common. And that would leave 1 plus x squared to the, let's see, we pulled out 3, 4 squared over 7. That'd be the 4/2, right? 4/2, I pulled 3/2 out. Minus 2, let's see. That would be 2 over 2, 1 plus x squared to the 1 power over 5. And plus 1/3 plus either that or that. I don't think you have to necessarily. I mean, some people would argue, why is this simpler than that? You have 3 terms here, here you have 3 terms, and then, so, I can see either way.
Where did you get the 7.5? I didn't get you on there.
Because when we took the integral of this,
Yeah.
you raise it by 1, which is 2 over 2,
Yeah.
so that becomes 7/2
Okay.
over 7/2, just like that's 5/2 over 5/2, 3/2 over 3/2. I think that's pretty good for you substitution. So, next week, and I'll post all this stuff on Canvas too. Whether we're here or not, we're gonna work on 6-6 and 6-7. Practice 6-6 and 6-7. Are we cool with that? Everybody's got everything they need for that? 6-6, 6-7.
Say it one more time.
6-7 and 6-6. I know what you mean. You frowned way before you.
Yeah. I'm practicing.
We do good.
Okay. We're doing pretty good, guys. So all you have to do next week is just the assignment. No new material really. We may have some questions about what you're working on, that's